Hello everyone, wherever you are. It's PPARɣ over here. Hope you are doing well. Right now I'm going to present a very interesting idea, and I really hope you like it. So let's start. So we asked a question: is pulmonary vascular disease reversible with the PPAR gamma agonists? Well, in order to be able to answer such a question, we should first divide it into 3 sections and know what is meant by pulmonary vascular disease and how does it develop, what is PPAR gamma and the effect of its activation, whether pulmonary angio-obliterative disease is really irreversible. Alright, so pulmonary angio-obliterative disease is the severe form of pulmonary arterial hypertension, where pulmonary arterial hypertension is a form of pulmonary hypertension and is categorized as a class 1 according to the Dana point classification. If left untreated, it carries a high rate of mortality, with the most common cause of death being cor pulmonale or the decompensated right-sided heart failure. The familial or the idiopathic types are the most common forms in the pediatric population, where congenital heart diseases places second among the causes and chronic respiratory disorders places third. So what's wrong that is going on in this disease process? The main pathologies involved in PH are vasoconstriction, vascular cell proliferation and migration, leading to remodeling, which involves all layers of the vessel wall, where at the earlier stages of the disease the remodeling is just confined to the small pulmonary arteries in the form of medial hypertrophy, where there is abnormal muscularization of the distal, normally non-muscular pulmonary arteries, as we can see here and here. In the long-standing disease, however, we can see intimal proliferation and fibrosis, seen in this picture and in this picture. It is these proliferation and fibrosis which leads to vascular obliteration and pruning observed in this chest X-ray. An additional feature observed in the very severe forms of the disease is the plexiform lesions. These lesions consist of phenotypically altered endothelial cells and a stroma of myofibroblasts. It is actually these lesions which are currently deemed irreversible. The other pathologies involved are thrombosis and inflammation, which is characterized by perivascular inflammatory infiltrates, which are often seen invading the vessel wall. It's currently understood that inflammation precedes the vascular remodeling, denoting that dysregulated immunity actually participates in the disease process rather than just being a consequence. Well, having said what have been said, we still need to know how did all of this develop. Well, there has been a debate about the core pathobiological mechanism involved in PH development, with the conventional proliferative paradigm stating that genetic and environmental factors interact to cause initial endothelial cell damage and sustained apoptosis. With time, the remaining endothelial cells will exhibit an apoptotic resistant and a hyperproliferative attitude, which will eventually lead to angio-obliterative remodeling, occlusive plexiform lesions, and the increased pulmonary vascular resistance and shear stress observed in the disease process, establishing a perpetuative cycle of the disease. Recently, however, the degenerative paradigm emerged as a rationale explaining the disease with some supporting evidence. It suggests that the initial endothelial cell damage and sustained apoptosis may directly contribute to the dropout of fragile precapillary arterioles, leading to microvascular rarefaction and hence the increased pulmonary vascular resistance and shear stress. As it is seen, the degenerative paradigm stands in face of the proliferative paradigm and suggests that the proliferative lesions may occur as a consequence of microvascular rarefaction and increased pulmonary vascular resistance rather than being the primary inciting cause of the microvascular rarefaction, providing the premise for stating that altered pulmonary hemodynamics is a prerequisite for plexiform lesions to form, and that mechanisms other than the proliferative vascular obliteration may be incriminated for causing the hemodynamic abnormalities in the first place. So regardless of which paradigm operates, to cause PAH both share the fact that initially the pulmonary artery endothelial cells dysfunction and undergoes apoptosis, and that eventually angio-obliterative remodeling will happen. Well, the exact molecular pathways through which all of this is brought about aren't really under the scope of this presentation, but I'm going to have a quick overview about their nature. Well, the pathological changes observed in PAH are actually attributed to abnormalities in multiple molecular pathways and genes regulating pulmonary artery endothelial cells and smooth muscle cells, involving alterations in vasoactive mediators with the increased serotonin, angiotensin, and endothelin signaling, and the decreased expression of voltage-gated potassium channels and decreased expression of nitric oxide, all of which will lead to the increased vascular tone and the increased vascular cell proliferation and migration. In addition, we have the hypoxia-induced activation of hypoxia-inducible factors, leading to the increased intracellular calcium signaling, which will again lead to the increased vascular tone and the increased vascular cell proliferation and migration. We have abnormalities in growth mediators, leading to the increased cell proliferation. And interestingly, we have bone morphogenetic protein receptor 2 mutations, which are actually present in more than 70 to 80% of familial cases and in 10 to 20% of idiopathic cases. Bone morphogenetic protein receptor 2 actually belongs to a family of receptors known as the transforming growth factor beta family of receptors, which normally functions to promote endothelial cell survival and migration, and to suppress smooth muscle cell proliferation. Therefore, such mutations will lead to the increased vascular cell proliferation in the form of smooth muscle cell proliferation, and the increased liability of endothelial cell to apoptosis and the perivascular inflammation. It is worth noting that most of the functions of the bone morphogenetic protein receptor 2 are actually mediated through the ability of PPARɣ to form a complex with beta-catenin, which is seen in the first bullet point of the blue rectangle. Lastly, we have alterations in inflammatory mediators, which will again lead to the increased vascular cell proliferation and inflammatory cell recruitment, all of which will eventually lead to the vasoconstriction and angio-obliterative remodeling observed in the disease process. Well, now that we have known what the disease looks like and how does it develop, we still need to learn more about PPARɣ and the effect of its activation. Well, PPARɣ, or peroxisome proliferator-activated receptor gamma, is one of a group of 3 nuclear receptors that function as a transcription factor, and when activated they bind to PPAR response elements in the promoter regulatory regions of target genes, thus regulating metabolism, cellular differentiation and development, inflammation and tumorigenesis. PPARɣ is widely expressed in normal pulmonary artery endothelial cells, smooth muscle cells, and endothelial progenitor cells. Thus, PPARɣ activation can actually lead to, it can induce pulmonary artery smooth muscle cell apoptosis and reverse remodeling attributed to such proliferation. It can attenuate angiotensin, endothelin, and serotonin-mediated vasoconstriction. It can enhance endothelium-dependent vasodilatation, and it can potentiate the angiogenic capacity of endothelial cells and endothelial progenitor cells. PPARɣ activation has also some anti-inflammatory properties. Thus, it looks like PPARɣ activation can actually tackle every single abnormal molecular pathway involved in PAH development, and it does so simultaneously. Unfortunately, the currently available medications which are known to mediate pulmonary vasodilatation are palliative, in that they can only improve symptoms and slow down disease progression, but they are ineffective in reversing the vascular remodeling and preventing the deterioration and the need for a lung transplantation in the long-standing disease. On the other hand, PPAR gamma agonists are presented as a promising potential future therapeutic option which can possibly ameliorate the full-blown pulmonary angio-obliterative disease, which is currently deemed irreversible. So is it really irreversible? Well, as we have seen, there are at least two types of remodeling that are attributed to smooth muscle cell proliferation and muscularization, and that are attributed to endothelial cell proliferation, where we have a hyperproliferative, apoptotic resistant, and phenotypically altered endothelial cells. It is worth noting that the reversal of vascular remodeling reported in the previous studies actually described reduction of muscularization in chronic hypoxia-induced and monocrotaline-induced models. In contrast to the human disease, both types of models lacked the clustering accumulation of proliferating endothelial cells in the lumen of pulmonary arteries. This mass of proliferated cell population actually represents a stable population with a very low turnover rate. So, unlike pulmonary artery smooth muscle cells, whether these phenotypically altered endothelial cells can switch back to a normal monolayer forming cells remains unknown. Therefore, further studies in which animal models with the severe form of PAH simulating a severe human disease are needed to find out if lesions caused by altered endothelial cells can be reversed. So for the conclusion, as we have seen, it's quite obvious that the pathobiology of PAH is so intricate, involving many different metabolic, inflammatory, and genetic pathways. The strongly emerging degenerative paradigm implies that a regenerative therapeutic strategy should be adopted to restore and promote the lung microvasculature rather than just relying on the old notion of disobliteration of the small pulmonary arteries. PPARɣ gamma agonists have the advantage of addressing multiple molecular abnormalities simultaneously, and the beneficial impact of PPARɣ gamma activation is multifaceted in that it affects metabolism, inflammation, and genetics, which are the three critical pillars contributing to PAH development. And we need to remember that the severe forms of PAH involve plexiform lesions with altered endothelial cells. The question of whether PPARɣ gamma agonists can switch such cells back to a normal monolayer forming cells still remains unanswered. Therefore, animal-based studies using models with severe forms of PAH are necessary to find out if PPARɣ gamma agonists can truly induce reversal in the phenotypically altered cells, to determine whether they can be successfully used in the future treatment of the pulmonary angio-obliterative disease, which is currently deemed irreversible. If found to be possible, PPARɣ gamma agonists may one day substitute the need for cardiopulmonary transplantation, which remains an obstacle in many areas of the world. Isn't this a wow? I think this is fascinating, so I'm going to allow a few seconds for you to imagine. So watch out. The irreversible might turn out to be reversible at the end, and all that is needed is to adopt a regenerative therapeutic strategy. I really wish we can someday launch a primary study, to prove whether this is possible. Thank you for your attention. If anyone wants to have a detailed reading into the pathways involved in PAH development and the detailed pathways through which PPARɣ gamma acts, please use this DOI appearing on the screen, or just send me an email and I will provide the full PDF to the article. Thank you.